Hey everyone, happy Thursday. Here we are with some extensions of equations of circles. So the next level to writing equations, we're going to fold in what we've learned basically from parts of the year and earlier in this chapter. All right, number one, given the graphs below, write the equation for each circle. So your goal when you write the equation for each circle is to find, you've got to find the center and radius. And then you've got it, right? Every time. It'll be pretty easy to write. I'll write the date here. All right, and so if I look at circle D, I don't have the radius yet, but I could certainly figure it out. So if I look from here to here, my diameter is actually 14, because I go from 0 to 14 on the x, which means radius is 7. So that's nice. And then I have to find my center. So my center is right in the middle, and since it's a horizontal line, I know my y-coordinate still has to be 12, so it's got to match these. And then my x-coordinate has to be the middle number between 0 and 14, which is also 7. So here's my equation. X minus 7 squared plus y minus 12 squared equals 7 squared, so 49. Remember, that is 7 squared there. All right, now this one's a little trickier, but not impossible. So we can start again. We can find the diameter. So we got the 2 points, and if you have a slant on the grid, you just make a right triangle, and we use Pythagorean theorem again. So let's see, we go from 21 here to 45. So 45 minus 21 means that this side is 24. And then we're going to go from 10 on the y to 42. So this side is 32. So we're just going to use Pythagorean theorem for the diameter. Diameter squared equals 24 squared plus 32 squared. And if we write that real quick in our calculators, which I'm doing right now, diameter squared equals 1600. So the diameter equals 40, which means the radius is half of that, 20. Okay, now we have to find the center. So, it's just the middle number. Okay, so when I'm looking for the center, I'm actually just going to take the average of the x values, which means I'm going to add the two x values together and then divide by 2. Then I'm going to take the average of the y values and divide by 2 as well. So my center is 33, 26. So here's my equation. X minus 33 squared plus y minus 26 squared. And then I have to square 20, so that's 400. So that's 20 squared. Okay? If you want to write a note to yourself, what I did here for the center was find the midpoint on the grid. Find the midpoint of a segment. So if you have 2 points, your midpoint is the 2 x coordinates added together, divide by 2. And then the 2 y coordinates added together, divide by 2. So if you want to write that down somewhere, it'll definitely show up on your homework again. All right. Now looking at question 2, we look at question 1, and we're actually going to look back at circle H, this one. Complete the equation for the tangent line through L. So for question 2, we're going to have this tangent line. And if we want the line, we want the perpendicular slope. And the point we're going to actually use is L. And that is at 45, 42. Okay? So how do we find out the slope? Well, you found out the center here for H is 33, 26. I'm going to zoom in a little bit. Ooh, that looks good. If I make a slope triangle, a rise over run. Right now this is at 33 and this is at 26. So my rise is 16 and my run is 12. Okay? Which means, and I'm going to zoom out here, which means my radius slope is positive 16 over 12, which reduces to 4 over 3. So my tangent line slope has to be perpendicular to that. Remember, perpendicular slope has to be the opposite reciprocal of that. So it is not just 3/4, it is negative 3/4. And that negative can be on the 3, right in the middle, or on the 4, just in one spot. So when you write your equation for your tangent line, you move this, oh actually, yeah, let me move this over a little bit. Okay, so we have all those thoughts there. We're actually going to use point slope form, which is something I assume that you learned from last year, but we will review it real quick. Point slope form for your equation. Y minus y1 equals m times x minus x1, where m is slope, and then x1, y1 is a point on the line. Hopefully you're starting to see this is some algebra review that your teachers are going to expect you to know for next year. So we're going to look back at our information. This is our y1, this is our slope, this is our x1. Well, I have my slope here. That's easy. So negative 3/4. And then x1 is this, my x-coordinate of my point that I want, and my y-coordinate. And notice there's a minus there, so you're going to take the opposite sign. So y minus 42 equals negative 3/4 times x minus 45. All right? And remember, for any of this video, you can pause and rewatch it if it doesn't make sense. All right, number 3, given the diagram as shown, and r is at negative 30, 15. ST is 10. And ST is also 12 units away. Ooh, so this is a radius chord question. So I have that. And I want to write an equation for circle R. I already have the center. That was given. Nice. I just need the radius. And since it's a circle chord equation, let's zoom in here. Just draw the radius in a really convenient spot. And if you remember, you just use Pythagorean theorem. So I've got a triangle, 5, 12, and then r. So r squared equals 5 squared plus 12 squared. R squared equals 25 plus 144. R squared equals 169. So my radius is 13. Okay? Find out it's 13. So our final equation is x, and we're going to do the opposite signs again. Plus 30 squared plus y minus 15 squared, and then I'll square the 13 to get 169. Okay? Awesome. So there's circle equations and radius chord relationships. All right, there is one more here. That is an extension. This one looks long, but it's not so bad. I'm just asking you to think of, that should be arc over there, to try to remember a few things from earlier in the year. Okay? Segment FG is vertical with a length of 112. Oops. And since I have a radius going through it, I know it's bisected. So 112, that whole thing is 112, so this is 56 and that's 56. And then I do know the radius. Radius is the square root of that number. That's a really large number. The square root of 4,225 is 65. All right, so those are all the things I know. Ooh, find the coordinates of h. So in order to do that, I actually need to find out what that length is for segment OH here. And if you look, you have a right triangle already, and so you can use Pythagorean theorem for that. So x squared plus 56 squared equals 65 squared. So x squared plus 3,136 equals 4,225. And when I move that over, I've got x squared equals 1,089. And believe it or not, I believe that's a perfect square. But I wrote something in my calculator that made my calculator not want to do it. All right, so x equals 33. So if I look in my picture now, this length is 33. All right, and it's a horizontal length. So that means h is 33 units from the origin. So the coordinates for h is 33 to the right and 0 up. Okay? Now we're going to use our trig skills to find the measure of angle FOH. So I'm going to redraw the triangle here. And because we have all the sides at this point, you can use any right triangle trig function that you like. I'm going to call this y. So I'm going to use tangent because that's my favorite. I don't know why. Tangent of y equals the opposite side, 56, over the adjacent side, 33. And remember, when you're solving for an angle, to undo the tangent, you do the inverse tangent. And just round to the nearest, oops, that disappeared. Round to the nearest degree would be amazing. So this is about 59 degrees. Okay, that will definitely be on your homework. Now we use our answer from question 4b, to find the length of arc FG. All right, the length of arc FG is, we're looking at the arc length here. So we've got to take, if this angle is 59, then this arc is 59 degrees, which means this arc is also 59 degrees because you get the same thing here. So 59 times 2 means our arc degree is, arc measure is 118 over 360 times diameter. My diameter would be 2 times 65, just 130. So 130 pi. And if you could give me 2 decimal places for that, that would be awesome. It's about 133.87. Okay. Last thing, now write the equation for the radius this time. Okay. You have a couple options here because you actually have 2 different points. You can use O and say, oh, okay, I can use 0, 0, or you can use F, which is, now we know, 33 to the right, based on our right triangle, and 56 up. Okay? Now, if we look at our slope, we need our slope and a point. The rise is 56, the run is 33. You can leave it like that, and that's the most reduced that it will be. And then you can choose the point O, and you can say, I'm going to use 0, 0. So I could say y minus 0 equals 56 over 33 times x minus 0. And since it's zeros, you could just say y equals 56 over 33x. And that's because it starts at the origin. Or you could use the same slope, because you have to, and this new point. And you get y minus 56 equals 56 over 33 times x minus 33.